Welcome. Today we're going to talk about strings. Strings enable you to store characters, symbols, numbers, anything that you want, even backslashes. You could make a string of backslashes. So just hang on, and here we go. Okay, let's talk about strings. In this example, inside of the quotes, I have A plus CS. That would be my string. Inside of the quotes, I could have put numbers, punctuation marks, backslashes. It doesn't matter as long as it's inside the quotes. It's considered a string or part of the string. In the picture that I'm giving you, I've got 0, 1, 2, 3, 4, 5, 6, and then I've got the letters that match up with those corresponding positions. Sometimes you call 0, 1, 2, 3, 4, 5, 6 either the position, the index, the spot. Doesn't really matter what you call it. Just understand that that represents which letter is in that position in the string. In this example, we've got some instantiation examples. Typically, as we discussed in the prior units, when you instantiate an object, you use the reserved word new next to the constructor name. And the constructor is always named the same thing as the class. Strings are a little bit unique in that you can just point your reference at a string with quotes, and that's good enough. You don't have to do the new string because it does that for you automatically. You could also go ahead and call the constructor and do the new string thing if you want. In this picture, S is my reference and A plus comp size my string. Understand that S is not a string. It knows where one is. If you went out into memory and found S and say, hey, what do you got? S would say, here's the location of the string. You take that location, go there and find your string. In my picture, I've got S storing OXF5, and if I go to OXF5, then I would find the string that S is pointing to or referring to. Here's another example. The only difference on this one is I called the constructor. I said new string. Doesn't change anything. The only difference is it, has more words, more letters for you to deal with. But it essentially does the same thing as the slide that we just looked at. There's more to it than that, which we'll talk about down the road in a few slides later. But for now, just understand that there's, pointing a string or pointing a string reference at something with quotes around it, or pointing a string reference at something that calls the constructor is essentially doing the same thing. Strings. The string class has methods. The methods are what give you access to the private instance variables and data that it's stored inside the class. We've talked about this quite a bit now. The last unit we made methods inside of a class with instance variables. We shared data. The same thing's going on in the string class. The data inside is private. It's instance variables. It's actually being used to share that data amongst all the methods that you have, and strings have a lot of methods. Here's the first four we're going to look at, or actually the first three. One of them is overloaded. We've got the Caret method length, and then there's two versions of substring, one that has two parameters and one that has one. That's called overloading. I think we talked about that in the last unit, but you're going to hear that word and some of those terms as we go along. So the length method just tells us how many characters, how many things are there in between the quotes. In this example, we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 letters in between the quotes. It would work the same way if we had numbers, spaces, punctuation marks. None of that changes. The length method is a return method. It sends back how many characters there are between the quotes. We've talked about return methods as well. You can store the value returned by a return method in a variable, or you can just directly print it out, whatever works. Here's the Caret method. The Caret method goes to a provided index/position/spot and gets you the character stored in that position. I have another example, another picture below of the code that I've given you where we have A plus CS laid out in a row with all of the numeric values for those positions above each of the letters. So if I say s.caret 0, I go to that position, index, spot, like I said, whatever you want to call it. There's a lot of different ways to refer to it, but whatever is at 0, that's what it's going to print out. On the next line, I say s.caret 2. If I go to 2, I would find L, the L in A plus CS. And then if I go to 6, which is essentially length minus 1, I'm going to get S. Substring. Substring returns a group of characters or a single character. It just depends on how you're setting it up. But there's two versions of substring. One takes a starting and then an ending position, and one just takes a start and goes from there all the way to the end. So in our example, we have A plus CS, and we have sub equals empty quotes. Sub is what we're going to store each of the substrings in. If I say s dot substring 3, it's going to start at position 3 and go all the way to the end. So it's going to get me USCS. In the second example, I have substring 0, 3. It's going to start at 0, go up to 3, but it's exclusive of the upper bound. It's exclusive of 3, so it's going to get me 0, 1, 2. In the last example, I have substring 4, so anytime there's only one number, it starts at that position and includes that position, and then gets everything after that all the way to the end. Here I've just got a couple more of these. I'm just changing it up a little bit, changing the starts and the ends so that you can just see some different examples. And we're going to open this up in a code example in a few minutes. We'll make a bunch of changes to it to make sure that you totally understand what's going on. And here I have some single letter examples. 0, 1 would get us whatever was stored at position 0 because it's exclusive of the upper bound. So it's exclusive of 1. It's only going to get us the 0 character. The next one would get us what was at position 1. And then the last one will get us at what's position, spot, index 2. So these are just like Caret. The only difference with Caret returns a character where substring returns a string. That's not really that important yet, but as we go along, that's going to become more important because there's a significant difference between just a character and a string. Even if the string is one letter, that's different than a character that's just one letter. And we'll break that down more as we go. So you have some methods that are searching methods. Index of and last index of are methods that go through your string and search for particular values, whether it's a single string, single character, or a group of characters. So let's take a look at a couple of those. Index of is going to start at 0, and it's going to search from 0 towards the length, and it's going to return to you the index position, the spot, the location of the first letter of that string where it exists in the string. So if I say s.index of US, it's going to start at 0 and scan from 0 towards the end looking for the first occurrence of US. It will find the first occurrence of US starting at 3. So it's going to return the 3 because that's where the U starts in US. In the next example, I'm looking for C. So it's going to start at 0, scan along. It's going to find the first occurrence of C at position 5. And then lastly, I'm going to search for X. There is no X inside of my string, so it's going to return -1. So index of, last index of, anytime you're searching for something and it isn't there, it's going to return back -1. So index of starts at the beginning and goes towards length. Last index of starts at the last character at length -1 and scans towards 0. So last index of would start at length -1, start checking, and the moment that it finds that first occurrence of what you're looking for, it returns that position. So if I do last index of C, it's going to start at 6, going towards 0. It's going to find the C at position 5. And if I'm looking for plus, it's going to start at 6. It's going to scan backwards, and plus starts at position 1. So the last index of can get a little tricky because you're going from the back to the front, but it's exactly the same as index of, just starting at a different location. Now let's go take a look at some examples in code so we can break this down a little bit more. Okay, let's take a look at some string examples, some code examples. These are going to match up with the code segments that we were just looking at in the slide. So the first one that I've got here is length. And what I'm doing with length is I've made 3 different strings, one using the new string, the constructor, and then the other 2 where the constructor call is behind the scenes. So all I'm doing here is I'm putting a different number of letters inside of the quotes each time so that you can see what's going on. So if we run this one's pretty straightforward. I don't think you need me to do a whole lot with this one. Prints out 12a plus 5 and 7. If I had 4 more letters, 1, 2, 3, 4 inside of that first string that I've created, instead of it printing out 12, it'd print out 16. I could go in here and I could put, let's try this. I know how much I like backslashes. So I added 4 backslashes in there. Ooh, and notice with the backslash, 2 backslashes equals what? 1. So if I put 4 backslashes in there, you thought it was going to print out 20. It printed out 18. So just one of those things you can play around with. So if this is of interest to you, the backslashes are the only ones that's really kind of weird. But anyhow, so if I put 3 or 4 punctuation marks in there that were not backslashes, then I'd get the 20. So just some stuff for you to mess around with. But length tells you how many characters do you have inside of the quotes. The next one we need to look at is Caret. So with Caret, you're basically specifying which character you want. It's going to go there, get that character, and send it back. So if I say caret 0 in alligator, I get A. If I say caret 2 in alligator, I get L. And if I say caret 4 in alligator, let's run this, we're going to get G. So let's see, how could I change this up? If I say to get a character that's not there, if I go too far, that's a problem. So if I say get me caret 12, I don't think I have 12 letters. If I say get me caret 12, it goes out of bounds. So I can only specify a character that's inside the range of values that I have. So if I go beyond that range of values, it's going to give me an error. As long as I give it a number that's within the number of characters that I have, I'm good to go. Notice on the last example, I have defined character C, and I said caret 4, put that in C. That's the same thing along the lines when we did this with variables, when we're dealing with data types. We said something along these lines, I'm pretty sure. Let me get that fixed. We did something like that, right? Notice we have single quotes. Single quotes is a character, double quotes is a string. So when I did the S equals alligator, alligator is a string. When I say R equals A, that's a character. So the caret method returns a character. So that's different than substring. Anyway, just play around with this kind of stuff. You know, put some numbers in here, change it up, make sure that you totally understand how this works. And if you've got questions about it, that's why the examples are here. So let's jump on over to substring. Substring returns a string. It basically pulls out the characters that you want, constructs a new string with that, and sends you back that reference so that you can then point at it. That's what's going on. So if I say substring 3, it's going to start at the character at 3 and return that character plus everything after it all the way up to the length. So if I say substring 3, let's go ahead and run this. We're going to get USCS, because USCS starts at 3. It goes all the way through the end. If I say 0, 3, I'm going to get APL because it goes up to the 3 exclusive of the 3. And then on the last one, I'm just showing you how you can just get one character at a time. If I do 0, 1, I just get whatever character was at 0 because it's exclusive of the upper bound. If I did 1, 2, we can do that just so you can kind of see how that works. And then we run that, and now we get the second character because we said start at 1, exclusive of 2. Let's see, what would be something interesting that we could do? Let's say we go in here and we say substring 13, and we run that. Now we get an out of bounds exception because we don't have, there is no position 13 to start at, all right? And so we don't have that many letters. We only have 7 letters. What if we put 7 in here? Let's see, we have 7 letters. We put 7 in. Doesn't do anything, doesn't blow it up because it basically is at the end, and that's okay. If I come down here and say 0, 7, right, remember it's exclusive of the upper bound, and I run it again, I get everything that's there. That's kind of an interesting thing. So I back it up, 0, 6, I run it again, and now I get everything except the last letter. So these are the kind of things to mess around with. So we said 7 was fine, we got 7 letters, we're all good. What if we did 8? Ooh, look at that, that blows up, that's bad. What if we did -3? That's kind of cool. -3, what would that do? Ooh, that's out of bounds too, right? So that's not good. So these are the kind of things, like I said, that you need to mess around with. You go in here, you punch in some numbers, you can do all sorts of really strange stuff. You just need to go in here and try it out and make sure you know how it works. Let's go to index of. Index of is a search method. It starts at 0 and goes towards the end and looks to find whatever value you specified. Last index of starts at the end, goes backwards towards 0. So if I say s.index of US inside of this, I'm looking for that in the string A plus CS. It's going to start at 0 and work its way up, and then you're going to see that it's going to find US at position 3. So these are just the kind of things, once again, you mess around with. I ask it for C, that's at 5. I ask it for X. There is no X, so it's going to return -1. And then I go down and I search for PL. I get 1, and I search for plus. Remember, with last index of, it starts at length -1, going back towards 0. So it finds plus starting at position 1. So the last index of can sometimes feel a little counterintuitive because it returns the beginning of the string that you're looking for, but you're starting at the end and going back towards 0, so that can kind of a little weird. A lot of times people would think it would return the position of the last character in the string that you're searching for, but it doesn't. It returns the position of the first one. So just some stuff for you to mess around with. Make sure you use these examples. Spend some time with these to make sure that you understand how all this works. There are 2 more methods from the string class that we need to look at. One of them is equals, and one of them is compareto. And just to make sure I've mentioned it, the string is part of the java.lang package. But equals and compareto. The way equals works, equals goes to the strings that are being referred to and checks the characters in between the quotes of those two strings to see if they're exactly the same. So it's got to have the exact same number of letters, and they have to be in the exact same order in the exact same case, whatever it may be. So here I've got comp sci and comp sci. That's going to come back true because you have the exact same number of letters. They're all the same. They're in the same order. They're all the same case. We're good to go. On the last line, I have 1 dot equals comp. Well, comp sci does not match comp, so that one's going to come back false. So anytime I want to check to see if one string has the same letters as another string or the same characters, however you want to describe it, I'm going to use dot equals. The compare to method, this one's a little weird. This one takes a little getting used to, but compare to is what I'm using with an object, in this case a string object, to see which one's bigger than the other one. That's essentially what you're trying to do with the string. It's called lexicographical, but basically what it means is which one would come in the dictionary before the other one. That's kind of the way it works. So anyway, we've got the string region and the string UIL state. So if I compare 1 dot compare to 2, I'm comparing region and state. What I'm looking at is I'm basically comparing the ASCII value. I'm saying 1's ASCII value minus 2's ASCII value. What is the difference between those two? So basically the difference in ASCII between R and U, and they're 3 characters apart, so you get -3. So if I flip it around and I say 2 dot compare to 1, then the U comes first. So basically it's U minus ASCII value of R, which would get me 3 because the U ASCII value is bigger than R. This is one of those ones when we get into the string example and we look at the code, this one's going to make a whole lot more sense because right now it's kind of weird. And you got to remember your ASCII value. If you don't remember the ASCII value, then this is going to be difficult too. So if I point to at region, which is the same string that 1 is pointing at, and then I do a compare to, I'm going to get 0 because 0 means they have the exact same number of letters in the exact same number, same case in the exact order. Let's go take a look at this in action. Okay, let's take a look at compare to and equals in action. What I've done at the top of this example, I've listed out the ASCII values. Little a is 97, capital A is 65, 0 is 48. These are ASCII values that you just have to set to memory. You're going to use these throughout the course, and if you go do competition stuff, this is something also that's vital. So these 3 you got to know. So 1 is pointing at a string about, 2 is pointing at a string cabbage. If I say system out print line 1 dot compare to 2, what it's going to do is it's going to start at the first letter of about and look to see if that letter is the same in cabbage, which it's not. So it's going to say ASCII value of A minus ASCII value of C. Okay, so A is 97, C is 99. It's going to come back -2 because A, 97 minus 99 is 2. So I'll flip them around, and then I'll have C minus A, which would be 99 minus 97, I'd get 2. So the way compare to works is it starts at the beginning of both strings, and it looks at 0 and says, are the letters the same? If they are, it goes to 1. If they are, it goes to 2. Okay? The first set of letters that differ, that's the difference in ASCII that it's going to return. So A and C are different. If I change this to abbage and about, okay, and now I run this, okay, now I'm going to get 13 because A and A are the same, B and B are the same. Now it's going to return the difference in ASCII value between 0 and B. That's where you're going to get the 13 and the -13. So if they were all the same, and it's going to go 0 to 1 to 2 to 3 all the way down to the end of the line, it's going to return 0. But the first two characters in the sequence that differ, it's going to return that difference. So it looks at both characters in spot 0. Then it goes to 1. Then it goes to 2. So this is one of those ones where you really got to come into these examples and mess around for a little bit, because I think this one takes a little getting used to. This is one that when I explain it, I have to explain it several different times throughout the course of the year because it seems to be one that's a little tricky. Anyway, looks at the characters, the first 2 that differ, it returns the difference in ASCII value. So let's do this. Let's do capital A and a little a on this one, just so you can see how that works. And now you're going to get a difference of 32 because the ASCII value is 97 and 65. That's where you get the 32. You say, who came up with the ASCII table? It goes way back, but it was somebody that apparently Just wanted to mess with you by putting the numbers in some strange sequence like this. But it's all good. All right, down at the bottom, we're using equals. Equals is going to compare the letters in the two strings to see if they're exactly the same in the exact same order, in the exact same case, the exact same symbols, spaces, punctuation marks, whatever. And down at the bottom, we've got comp sci, they're both the same. That returns true, and then we compare comp sci to comp. That's not the same, it returns false. So if we want to come in here and just check this on the case thing, we put a capital letter in one, a lowercase letter in the other one. Now we run it returns false for the first one instead of true. Pretty much what we'd expect. Okay, we're going to talk about references in great detail, and we're going to talk about immutability. This is when you're dealing with strings. This is where things get kind of weird, because you think you know how it works, and then when you start looking at the stuff behind the scenes with what's pointing where, you realize real quick that you don't know how it works. And so there's a lot of details behind the scenes with strings that we're gonna try to look at that without going way off in the weeds. So let's just work with me here. Strings are immutable. What that means is once you make a string, once you make something inside of quotes, it's forever what's inside the quotes. There's no way to, there's a lot of methods with strings that look like they change what's in the quotes, but they do not. There's no method called set character at or change length. There's none of that. You can't make the string shorter. You can't go in and change its lowercase letters to uppercase letters. You can't change a letter to a number. There's no way to do that. You can make a new string based off of the old string's values, what's in between the quotes. You can use those things to build something new, but you cannot in any way change what was put inside those quotes originally. So, like I said, bear with me. This is going to get a little weird in a couple spots, but I think if you follow me, you should be all right when we're done. So, a reference points at something. We've looked at a lot of reference examples over the last few units. So, I can change where a reference points, but with strings, I cannot change what the reference is pointing at. So, once again, I can change where it's pointing, but I can't change the thing it's pointing at with strings, because strings are immutable. So in my example, I've got S is pointing at UIL. S is referring to UIL. Right now I'm good. So if I print out S, it goes out, prints out what it's pointing at, prints out UIL. On the third line, I say S equals A plus. I did not change UIL to A plus. I told S, stop pointing at UIL and go point at A plus. So what I did is I constructed a new string out in memory, and I told S to point there, don't point at UIL anymore. So UIL is still there. We just don't have any way to get to it because we don't have anybody pointing at it. So it's just kind of floating around all by itself going, hey, where'd everybody go? And that's just how that works. In this example, I have S pointing at UIL to start as well, just like in the prior example. And then instead of pointing S at another string, I point S at null, which is nothing. A lot of times when you see that, you're going to think, wow, S, we just turned UIL into null. And that's not at all what we did. Because S is not UIL, it knows where UIL is. So we told S, you don't keep track of UIL anymore. You go point at nothing, which is null. So now once again, UIL's floating around all by itself. Nobody knows where it is. So strings are immutable. You can't change what the reference is pointing at, but you can change where the reference is pointing. And this is one of those things you're really going to have to spend some time working with this before you totally get what's going on. But I think my diagrams should help. In this example, I'm just proving again that strings are immutable, and I'm also moving some references around so that you can kind of get an idea how that works. A lot of times when you see the to uppercase method, you assume it's going to the string, changing all of its letters to uppercase. That's not what it does. When you call to uppercase, it looks at the old string's characters or symbols or whatever, and it returns an uppercase version of the original. If it has letters and numbers in it, it just doesn't do anything to those. But all of the standard characters, it's going to uppercase those. So in this case, I have S pointing out at comp sci. I say print out what S is pointing at, prints comp sci. I then call S.to uppercase on a line all by itself. To uppercase, as I said before, is returning a brand new string. I didn't tell anybody where that new string was. I didn't print it out, so that line essentially has no effect. Because then when I go out.println S, I'm still all lowercase. Following that line, I say S equals S.to uppercase. Now I called the to uppercase method. It's going to send me a new string with everything from the original in uppercase. I now told S to point at that new string, stop pointing at the old one. So now whenever I print out S, I get uppercase comp sci. A lot of moving parts, I get that. This is one of those ones you might have to go through this section a few times and look at the examples and play around with them a little bit, and you still may be foggy. This may be we have to come back through this again and again a couple times before you totally get it, just like with the compare-to. And so I'm going to have this reference stuff in the videos and in the slides a couple different times because it gets a little tricky. So let's ramp it up even a little bit more. Here I've got X and Y both pointing at Chuck. We've already established strings are immutable. So because strings are immutable, once you create Chuck with quotes around it, Java only wants you to have one of those. So when you say X points at that Chuck, when you say Y points at Chuck, Y goes, oh, or Java says, whoa, I already have a Chuck out in memory. Y, you're going to point at the same place. So here in my example, X and Y store the same memory address because strings are immutable. Java doesn't want to have more than one Chuck floating around in memory. It just points everybody at the Chuck that was created whenever you said X equals Chuck after that. So if I had 10 variables all pointing at the string Chuck with quotes around it, Java would have them all pointing at the same one because it doesn't need more than one because you can't change it anyway. Okay, once again, there's a lot more going on behind the scenes, but just, work with me here and let's make sure we kind of got the general idea of what's going on. In this example, I started out the same way. X and Y are both pointing at Chuck. There's one Chuck. As you can see in the diagram, they're both pointing at the same place. Now I say X equals null. I now, just like in the example from a couple slides ago, I now tell X, stop pointing at Chuck, go point off at null. Did that change Y to null? No. X and Y were both pointing at the same object. I told one of them to go point somewhere else. Y is still pointing where it was before. So X goes to null, and Y still stays where it was. Okay, in this example, this is one of those examples. I'm going to show you this, and I'm going to show you the one after this. You're not ever going to do this, but you kind of need to know it exists. In this example, I'm telling X and Y to both point at Chuck, but I'm using the string constructor to make both. What that does, that forces Java to do what it doesn't want to do. Java does not want to make two versions of Chuck, neither which can change. But I'm forcing it to do that, because when I do the new string constructor, Java makes distinct objects for that string that have whatever it is that you specify. So here I'm making two strings, both of which store Chuck, neither one of which can change, and I'm eating up twice as much memory. Doesn't make any sense, but you can do that. So don't do this, but just know that you could if you wanted to. It's kind of like one of those top secret things, except for this one, it's top secret and doesn't make any sense. But anyway, in this example, I made a new string, but notice I only made one Chuck. And I told Y to point at the same one as X. And in this case, I'm not eating up twice as much memory because I didn't construct two strings. I just constructed one and pointed them both at the same place. And that's okay. That's a little more, makes a little more sense than the prior one. Let's go out and take a look at these examples to see if we can kind of clarify this a little bit more. Okay, let's take a look at concatenation and parsing. With concatenation, what we're doing is trying to make new strings. And sometimes we're just adding strings together to make new strings. Sometimes we're adding non-string values to strings to make new strings. So in this example, I'm adding the integer 17 to dog to make dog 17. And I'm adding cat to 19 to make 19 cat. So by combining the non-string values to a string, it creates a new string. So concatenation is the process of adding things together to make a new string where one piece always has to be a string. In this example, we're creating the new string a plus 7 by adding the old value of a plus 7 to create a new string. And so we didn't change the original a plus, but we just made a new string with that value plus tacking on 7. And the length of that would be 6 because we've added 1 to the length of 5. Here I have the double wrapper type, and I'm adding that in with 1 to create it 99.5, which has a length of 6. So each time we're doing the concatenation thing, we're creating new strings. It's just we don't always have to use just strings to do this. In this example, everything's just a straight string. We've got substrings, we've got original values that we're tacking together to build new strings. But for this concatenation example, it's only strings that we're putting together. With parseInt, we're taking an integer value that's a string and converting it into an actual integer value. So parseInt would take a string that was an integer and convert it into its actual integer. It'd have to be a legitimate integer, though. It couldn't have letters in it, and it couldn't have a bunch of crazy symbols in it. So it'd have to be just a straight integer value in order for the parseInt to work. There's multiple forms of parseInt, but for this one, it would have to be just a straight integer for that to work. Here I have parse double, same thing. As long as I have a legitimate double value stored in the string, I can convert that string into an actual double using parse double. So let's go take a look at concatenation and parsing in some code examples. Let's take a look at a concatenation example program and a parsing example program. So here we have exactly what was in the slides. Dog 17, 19 cats, kind of the same idea. So what we need to do now is let's play around with this a little bit. Make sure that you understand what's going on. So let's run this. Looks good. So now what I want to do on this one is I want to come in here and do 200 or 220 plus dog plus 17. Run it again. And notice that because there's a string in with the pluses, everything's converted to a string. This is one of the ones that we looked at with the print line and print examples earlier. So now I've got 220 dog 17 plus 10. A lot of people would think that would be 220 dog 27, but because you have a string in there, it converts everything to a string. So the concatenation with this one, all the numeric values are converted to strings to build the new string. And then 19 cat, that's what you would expect on that one. And then down here, just the same thing. We got the string, we're adding 7 to it. We get a plus 7, we print out the length. And now, because 1 is pointing at a new string, based on the combination of the two pieces, the length has increased. And then we have a plus and slash comp sign. We're doing a bunch of manipulation of substrings. That looks pretty good. Remember, with substring, it's exclusive of the upper bound. So I can reduce this down a little bit and get less characters to put together with my new string. Pretty straightforward. And the other one with the concatenation example, remember we're converting string values that basically contain numbers into those numeric values. As long as it's a legitimate integer value, we're good. So for this one, I'm going to put a punctuation mark in there. I'm going to put an @ sign. I'm going to run it again. And it's going to explode. Give me a number format exception because that's not a legitimate number. I should also be able to put in a letter and get the same result. There's a form of parsent that will do base conversion that will allow you to put letters and stuff in there, but we're not using that version. Same thing with the parse double. As long as it's a legitimate double value, it'll let you convert that into the actual number that it represents. So both methods are useful. If you need to convert strings into integers and string doubles into doubles, this is a very handy set of methods to know. This is the part where we wrap up and you get ready to go crank some code. So hopefully you feel better about strings. The first part of this video was pretty light. I talked about some methods and some basics, and then we slowly ramped our way up to some stuff that gets a little more tedious. Now understand, for programming and writing code, you're probably going to use the first part of the video more so than the latter part, but the latter part helps you understand more what's going on and exactly how things work. So hope you enjoyed it. Head out now and build some programs, have some fun, crank some code.